We are group 4. So we will going to discuss about the measures of skewness and kurtosis. First, we have skewness.
Measures of skewness. The term skewness refers to the statistical metric that is used to measure the asymmetry of a probability distribution of random variables about its own mean, and its value can be positive, negative, or undefined. The calculation of the skewness equation is done on the basis of the mean of the distribution, the number of variables, and the standard deviation of the distribution. There are 3 types of skewness: the positive, negative, and normal. First one is we have the positive skewness. If the given distribution is shifted to the left and when it's still on the right side, it is a positively skewed distribution. It is also called the right skew distribution. A tail is referred to as the tapering of the curve differently from the data points on the other side. As the name suggests, a positively skewed distribution, it assumes a skewness value of more than 0. Since the skewness of the given distribution is on the right, the mean value is greater than the median and moves towards the right, and the mode occurs at the highest frequency of the distribution. The second one is we have the negative skewness. If the given distribution is shifted to the right and with its tail on the left side, it is a negatively skewed distribution. It is also called a left skew distribution. The skewness value of any distribution showing a negative skew is always less than 0. The skewness of that given distribution is on the left, hence the mean value is less than the median and moves towards the left, and the mode occurs at the highest frequency of the distribution. So we have the normal or zero skewness. When a distribution has zero skew, it is symmetrical. Its left and right sides are mirror images. Normal distributions have zero skew, but they are not the only distribution with zero skew. An asymmetrical distribution, such as a uniform distribution or some bimodal, or we can call that a two-peak distribution, will also have zero skew.
Here are the steps in finding the skewness. Firstly, form a data distribution of random variables, and these variables are denoted by xi, or known as number of variables. Next, figure out the number of variables available in the data distribution, and it is denoted by n. Next, calculate the mean of the data distribution by dividing the sum of all the random variables of the data distribution by the number of variables in the distribution. The mean of the distribution is denoted by x. Next, determine the standard deviation of the distribution by using the deviations of each variable from the mean, xi minus x, and the number of variables in the distribution. The standard deviation is calculated as shown below. Finally, the calculation of skewness is done on the basis of the deviations of each variable from the mean, a number of variables, and the standard deviation of the distribution, as shown below. Here are the skewness formula for group data. For population, as you can see in the formula below, where f is frequency, x is number of variables, and mu is population mean. For sample, as you can see in the formula below, where f is frequency, x is number of variables, and x bar is sample mean. And here are the skewness formula for ungrouped data. For population, as you can see on the formula below, where x is number of variables, capital N is number of population, and mu is population mean. For example, as you can see on the formula below, where x is number of variables, small n is number of samples, and x bar is sample mean.
Examples of skewness. Example of skewness grouped data. So here is the example of skewness. So we have the summer camp in which 20 students assigned certain jobs that they performed to earn money to raise funds for a school picnic. However, different students earned a different amount of money. Based on the information given below, determine the skewness in the income distribution among the students during the summer camp. So the following data is for the calculation of skewness. We have here the money earned of the students and the number of students. So before proceeding to the other steps in skewness, we will going to find the summation of the number of variables. To find the summation of number of variables, we will going to add each of the variables here in the number of students. N equals 2 plus 3 plus 5 plus 6 plus 4 is equals to 20. So we will have N equals 20. And now we will going to calculate the midpoint of each of the intervals. We can find the intervals here in the data of money earned. In finding the midpoint, we will going to add each of the intervals here in this data. For example, 0 plus 50, and then we will going to divide it by 2. So let's proceed. 0 plus 50 divided by 2 is equals to 25 pesos. And next, the data here. 50 pesos plus 100 pesos is equals to 150 pesos divided by 2 is equals to 75 pesos. 100 pesos plus 150 pesos is equals to 250 pesos divided by 2 is equals to 125 pesos. 150 pesos plus 200 pesos is equals to 350 pesos divided by 2 is equals to 175 pesos. And lastly, we have the data here, the 200 pesos and 250 pesos. 200 pesos plus 250 pesos is equals to 450 pesos divided by 2 is equals to 225 pesos. So the next step is we will going to find the mean of the distribution. To find the mean of the distribution, we will going to use this formula over here. So now we will going to multiply the midpoints here and the variables here. So first, we have 25 times 2 is equals to 50. 75 times 3 is equals to 225. 125 times 5 is equals to 625. 175 times 6 is equals to 1050. And 225 times 4 is equals to 900. So now, we will going to add all the results here, which is this one. So we will going to add 50 plus 225 plus 625 plus 1050 plus 900, which is equals to 2850, and we will going to divide it by 20, which is the n. So 2850 divided by 20 is equals to 142.5. So the mean of the distribution here is this one, 142.5. And now, we will going to find the squares of the deviations of each of the variables, which can be calculated as squared of the result of midpoint times mean. So now, we have 25, the first midpoint that we can find here, times 142.5, which is the mean, equals to 3,562.5, and we will going to square it, which is equals to 13,806.25. Next is we have 75 times 142.5, and we will going to square the result, which is equals to 4,556.25. And next, we have 125 times 142.5, and the result we will going to square it, which is equals to 306.25. And 175 times 142.5, and we will going to square it again the result, which is equals to 1056.25. And the last one is we have 225 times 142.5, and we will going to square it again the result, which is equals to 6,806.25. So the results here are the squares of the deviations of each variables. And now, we will going to calculate for the standard deviation, which can be calculated with this formula over here. Note that this formula that we're going to use is a sample formula from a group data. So the formula is sample is equals to summation of frequency times the squares of the deviations of each variables over n minus 1. So first, we will going to multiply the squares of the deviations of each variables and the variables of these data. So we have first the 13,806.25 times 2 is equals to 27,612.5. The next one is we have 4,556.25 times 3 is equals to 13,668.75. And next we have 306.25 times 5 is equals to 1,531.25. The next one is we have 1,056.25 times 6 is equals to 6,337.5. And lastly, we have 6,806.25 times 4, which results to 27,225. So we have here 20 minus 1. And we will going to find the sum of the results over here. These numbers. So we have 27,612.5 plus 13,668.75 plus 1,531.25 plus 6,337.5 plus 27,225 is equals to 76,375, and 20 minus 1 is equals to 19. So 76,375 divided by 19 is equals to 4,019.7. So we will going to find the square root of this number. which is equals to 63.40. So our standard deviation is 63.40. So let's calculate for the cubes of the deviations of each variables, like what we did over here. But we just calculated the squares of the deviations of each variables. So let's proceed. Cubes of the deviations of each variable can be calculated as cube of the result of midpoint times mean. So first, we have 25, the first midpoint over here. 25 times 142.5, which is the mean, is equals to 3,562.5. So we will going to cube it, which is equals to 1,622,234.4. And next we have 75. 75 times 142.5 cube is equals to 307,546.9. And 125 times 142.5 cube is equals to 5,359.4. And 175 times 142.5 cube is equals to 34,328.1. And lastly, we have 225 times 142.5
Example
cube
of
is
skewness
equals to
and grouped data.
561,515.6. So here are the cubes of the deviations of each variables. And then let's proceed. And finally, we will going to calculate for the skewness of the distribution, which can be calculated with the formula over here. Please note that this formula that we're going to use is a simple formula of skewness. So we have here skewness is equals to summation of frequency times the cubes of the deviations of each variables over the summation of frequency minus 1 times the cube of standard deviation. So first, we will going to add all of the cubes of the deviations of each variable. So we have here 1,622,234.4 plus 307,546.9 plus 5,359.4 plus 34,328.1 plus 561,515.6, which is equals to 2,530,984.4. So we have the summation of frequency, which is 20 minus 1 is equals to 19. And the cube for our standard deviation is 254,840.104. Now we will going to multiply these two over here. So 19 times 254,840.104 is equals to 4,841,962. So we will going to divide that. 2,530,984.4 divided by 4,841,962 is equals to 0.5. So our skewness is 0.5. Therefore, the skewness of the distribution is 0.5, which indicates that the data distribution is a right skew or a positive skewness since it's more than 0.
Skewness of ungrouped data.
The skewness and group data. So the formula of skewness is summation of cube of number of variables minus population mean over cube of number of population times population standard deviation. So here is the example of the skewness and group data. So find the populations of Skewness from the following data. The variables are 85, 96, 76, 108, 85, 80, 100, 85, 70, and 95. So the first step, the step one is to find the mean of the distribution. So this is the formula. Mean equals summation of number of variables over number of population. So the number of variables are the 85, 96, 76, 108, 85, 80, 100, 85, 70 plus 95 over the number of population, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So next, we need to add all the number of variables. So 85 plus 96 plus 76 plus 108 plus 85 plus 80 plus 100 plus 85 plus 70 plus 95 equals to 880 over the number of population, which is 10. So we need to divide the number of variables and the number of population, which is the result is mean equals 88. So step 2, we need to subtract the mean from each data value, which is the number of variables minus mean. So the first variable, 85, minus the mean, which is 88, equals negative 3. So 96 minus 88 equals 8. 76 minus 88 equals negative 12. 108 minus 88 equals 20. 80 minus 88 equals negative 8. 85 minus 88 equals negative 3. 100 minus 88 equals 12. 85 minus 88 equals negative 3. 70 minus 88 equals 18. And 95 minus 88 equals 7. Step 3, we need to square each result calculated from step 2. So first, negative 3 squared is equal to 9. 8 squared is equal to 64. Negative 12 squared is equal to 144. 20 squared is equal to 400. Negative 8 squared is equal to 64. Negative 3 squared is equal to 9. 12 squared is equal to 144. 3 squared is equal to 9. And 18 squared is equal to 324. And 7 squared is equal to 49. In step 4, we need to cube each result that we calculated in step 2. So first, negative 3 cubed is equal to negative 27. 8 cubed is equal to 512. Negative 12 cubed is equal to negative 1728. 20 cubed is equal to 8000. Negative 8 cubed is equal to 512. Negative 3 cubed is equal to negative 27. 12 cubed is equal to 1728. 3 cubed is equal to 27. Negative 18 cubed is equal to negative 5832. 7 cubed is equal to 343. So in step 5, population standard deviation. So here is the formula of the population standard deviation. Population standard deviation is equals to square root of summation of squared of number of variables minus mean over the number of population. And now, we're going to find the sum of the square result in step 3. So first, we have 9 plus 64 plus 144 plus 400 plus 64 plus 9 plus 144 plus 9 plus 324 plus 49 is equals to 1216 over the number of population. So now, we're going to divide 1216 divided by 10, which is the number of population, which is equals to 121.6. And now, we're going to find the square root of 121.6, and it is 11.0272. So, the population standard deviation is 11.0272. And now, we're going to calculate the skewness. So here's the formula. Q equals summation of cube of number of variables minus population mean over cube of number of population times population standard deviation. Now, we're going to find the sum of the cube result in step 4. First, the negative 27 plus 512 plus negative 1728 plus 8000 plus negative 512 plus negative 27 plus 1728 plus 27 plus negative 5832 plus 343, and the result is 2430. And now we're going to find the cube of the population standard deviation, which is 11.0272. And the result of the cube is 1340.9123. Now we're going to multiply the number of population, which is 10, to 1,340.9123 is equals to 13,409.123. And now, we're going to divide 2,430 divided by 13,409.123 is equals to 0.18. And now, we're going to round it off, and it is equal to Q equals 0.2. And therefore, the skewness of the distribution is 0.2, which indicates that the data distribution is a right skew or positive skewness since it's more than 0.
Second, we have kurtosis.
The term kurtosis refers to the statistical measure that describes the shape of either tail of a distribution. It indicates whether the tail of distribution extends beyond the positive negative 3 deviation of the mean or not.
There are three types of kurtosis: leptocortic distribution, mesocortic distribution, and platykurtic distribution.
First type is leptocortic or heavy-tailed distribution. Are statistical distributions with kurtosis greater than 3. Leptocortic distributions are more kurtotic than a normal distribution. They have a kurtosis of more than 3 and an excess of more than 0. The second type is mesocortic or medium-tailed distribution. Have a kurtosis of 0, meaning that the probability of extreme, rare, or outlier data is close to 0. Mesocortic distribution have the same kurtosis as that of the normal distribution or normal curve, also known as a bell curve. The last type is platykurtic distribution or short-tail distribution. Have less kurtosis of normal distribution. It is sometimes called negative kurtosis since the excess kurtosis is negative. Platykurtic distribution have a low frequency of outliers.
Steps in finding the kurtosis. Step 1 is form a data distribution, determine the number of variables in the distribution, which is denoted by n. Next is compute the mean, which is all the aggregate of all the variables in the distribution, and then divided by the number of variables and variables in the distribution. So in the step 3 is to determine the fourth moment of distribution by summing up the fourth power of deviation between each variable and mean. In the step 4, next is to determine the variance or second moment of the distribution by summing up the square of deviation between each variable and mean from the step 2, and then divided by the number of variables in the distribution. Lastly, the formula for kurtosis can be derived by dividing the fourth moment from the step 3 by squared second moment of this distribution from step 4 as shown below.
This is the Kurtosis formula from group data. Let us begin solving the population. Summation of x minus mu raised to the power of 4 over n times standard deviation raised to the power of 4, where x is the number of variables, n is the number of population, and mu is the population mean. Next is solving sample from group data. Summation of x minus sample mean raised to the power of 4 over n minus 1 times s raised to the power of 4, where x is the number of variables, next is the sample mean, and lastly n is the number of samples. Next is the formula in solving sample for group data. Summation of frequency times x minus sample mean raised to the power of 4 over summation of frequency minus 1 times standard deviation raised to the power of 4, where f is the frequency, x is the number of variables, and lastly, the sample mean.
Examples for kurtosis. Kurtosis grouped data.
So here's the example of group data. So the following data represents the age distribution of a sample of 100 people covered by health insurance. So here is the number of variables: 23 plus 17 plus 15 plus 20 plus 25 is equal to 100. So step 1, how to get the midpoint. So after we add the age of 25 and 34, we need to divide it by 2 is equal to 29.5. So 35 plus 44 divided by 2 is equal to 39.5. 45 plus 54 divided by 2 is equal to 49.5. 55 plus 64 divided by 2 is equal to 59.5. 65 plus 72 divided by 2 is 69.5. Step 2. Find the mean of the distribution using this formula. Mean is equal to summation of f, difference of the midpoint, over n. N is our total number of variables. So we have here 29.5 times 23 plus 39.5 times 17, 49.5 times 15, 59.5 times 20, and 69.5 times 25, all over 100. So the result is here. But after we add all the numbers here, we need to divide to the denominator, which is the 100. And so step 3, find the deviation of each data value. So here we have here our midpoint, which is 29.5, 39.5, 49.5, 59.5, and 69.5, which is minus 50.2, which is our mean. So is equal negative 20.7. 39.5 minus 50.2 is equals to negative 10.7. 49.5 minus 50.2 is equal 0.7. 59.5 minus 50.2 is equal 9.3. 69.5 minus 50.2 is equal 19.3. So here in our step 4, the squares of the deviation can be calculated as using this formula. So x minus bar x squared. Negative 20.7 squared is equal 428.49. Negative 10.7 squared is 114.49. Negative 0.7 squared is 0.49. 0.3 squared is 86.49. 19.3 squared is 372.49. So in step 5, the cubes of the deviation can be calculated as x minus bar x cubed. So we have here negative 20.7 cubed is equal 8,869.74. Negative 10.7 cubed is 1,225.4. Negative 0.7 cubed is equal to 0.34. 9.3 cubed is 804.36. 19.3 cubed is 7,189.6. So here in step 3, the quartic of the deviation can be calculated as x minus bar x to the fourth power. Negative 20.7 to the fourth power is equal to 183,603.68. So negative 10.7 to the fourth power is 13,107.96. So negative 10.7 to the fourth power 13,107.96 and so on. So here in our step 7, we need to calculate the sum of the squares using this formula, summation of f x minus bar x squared. So we have here 428.49. We add all of them and the result is 1002.45. So lastly, we need to calculate the standard deviation. So sigma is equal to summation of x minus bar x squared over n negative 1. So here is 1002.45 over 100 minus 1. So 99 is equal, so we have here sigma is equal 10.1. So to calculate the kurtosis, we have here the formula. Kurt is equal to summation of f difference x minus bar x to the fourth power of all over summation of f minus 1 sigma fourth power. So is equal to 342,949.2 over 100 minus 1 times 10.4 to the fourth power. Since the kurtosis distribution is less than 3, it means it is a platykurtic kurtosis.
Kurtosis and grouped data.
Now, I will explain how to find the kurtosis of the ungrouped data. So this is the example. Consider the following set of data values and find the kurtosis. 23, 34, 38, 47, 59, 63, and 84. To find the kurtosis, we have to first find the mean. So this is the formula for the mean. Mu equals summation of x divided by n. So mu equals summation of x divided by n. X are the variables and n is the number of variables. 1, 2, 3, 4, 5, 6, 7. So we have to add all of the variables. 23 plus 34 plus 38 plus 47 plus 59 plus 63 plus 84 divided by 7 equals 348 divided by 7 equals 49.7. Therefore, the mean is 49.7. Step 2. Find the deviation of each data values. The formula is x minus mean. X, the variables, and 49.7, the mean. So 23 minus 49.7 is equal to negative 26.7. 34 minus 49.7 equals negative 15.7. 38 minus 49.7 equals negative 11.7. 47 minus 49.7 equals negative 2.7. 59 minus 49.7 equals 9.3. 63 minus 49.7 equals 13.3. And 84 minus 49.7 equals 34.3. 3. The squares of the deviations can be calculated as x minus mean squared. So in step 3, you have to square all of the results from step 2. Negative 26.7 squared equals 713.65. Negative 15.7 squared equals 246.94. Negative 11.7 squared
equals 137.23. Negative 2.7 squared equals 7.37. 9.3 squared equals 86.49. 13.3 squared equals 176.51, and 34.3 squared equals 1175.51. Step 4. The cubes of the deviations can be calculated as x minus mean cubes. So in step 4, you have to cube all of the results from step 2. So negative 26.7 cube equals negative 19,065. Negative 15.7 cube equals negative 3,880.5. Negative 11.7 cube equals negative 1,607.5. Negative 2.7 cube equals negative 19.99. 9.3 cube equals 800.66. 13.3 cube equals 2,345.06. And 34.3 cube equals 40,303.2. Step 5. So in step 5, you have to raise all the results from step 2 to the power of 4. So the formula is x minus mean to the power of 4. So negative 26.7 to the power of 4 equals 509,301. Negative 15.7 to the power of 4 equals 60,978.8. Negative 11.7 to the power of 4 equals 18,830.6. Negative 2.7 to the power of 4 equals 54.28. 9.3 to the power of 4 equals 7,434.66. 13.3 to the power of 4 equals 31,155.9. And 34.3 to the power of 4 equals 1,381,824. Step 6. Calculate the sum of the squares. So in step 6, you have to add all the results from step 2. So the formula is summation of x minus mean squared equals 713.65 plus 246.94 plus 137.23 plus 7.37 plus 176.51 plus 1,175.51 is equal to 2,543.4. Step 7. Calculate the standard deviation. The formula for standard deviation is standard deviation equals square root of summation of x minus mean squared divided by n equals square root of 2,543.3 divided by 7 equals square root of 363.33 equals 19.06. Therefore, the standard deviation is 19.06. Calculate the kurtosis using the formula. Kurtosis equals summation of x minus mean to the power of 4 divided by n times standard deviation to the power of 4. So kurt equals summation of x minus mean to the power of 4 divided by n times standard deviation to the power of 4. To get this number, you have to add all the results from step 5. 2,09,579 divided by 7 times 19.06 equals 2,09,579 over 7 times 131,974.97 equals 2,09,579 divided by 923,824.82 equals 2.18. Therefore, the kurtosis of the distribution is 2.18. Since the kurtosis of the distribution is less than 3, it is a platykurtic kurtosis.